Now next topic, angular momentum and torque of a system of particles and conservation of angular momentum. Suppose we have a system of n constituent particles and the angular momenta of individual particles are suppose L1, L2, L3 up to Ln. Then the total angular momentum of a system of particles, that is nothing but the vector summation of the angular momentum of individual constituent particles. So we can write the total angular momentum of a system of particles, capital L, that is L1 plus L2 plus L3 up to Ln. Now suppose the angular momentum of any ith particle, that is Li. So we can write Li, that is Ri cross Pi. Now we can write the total angular momentum of a system of particles, that is the summation of angular momenta of each and every constituent particle. So we can write this equation in the form of the sigma. So L equal to sigma Li, that is sigma Ri cross Pi, and here we have to take I, that is equal to 1 to n. Now differentiate this equation with respect to time t. Okay, so we can write now dl by dt, that is d by dt of sigma Li, that is sigma dli by dt, and we can write the rate of change of angular momentum, that is equal to torque acting on that particle. So we can write this is equal to sigma tau I. Now the vector summation of the torque acting on each and every particle, that will give you the net or resultant torque acting on a system of particles. Now see here, we get dl by dt, that is equal to tau. So here at present we can't say this is with analogy of the Newton's second law of motion or Newton's second law of motion for a rotational motion, because this resultant or net torque acting on a system of particles, that is the summation of internal torque as well as external torque. So resultant torque tau, that is tau external plus tau internal. Okay. Now here tau external, that is sigma Ri cross Fi external. Similarly we can write tau internal, that is sigma I Ri cross Fi internal. But here as per Newton's third law of motion, we know this Fi internal, that is equal to 0, because if we think about the force acting on particle number 1 by 2 or force acting on 2 by 1, both the forces will be equal in magnitude but opposite in direction. So the vector summation will be 0. So in that way we can say Fi internal, that will be 0, right? So if Fi internal, that is equal to 0, then tau internal, that is also equal to 0. So net torque or resultant torque acting on a system of particles itself is tau external. So we can write dl by dt, that is tau external. Now we can say the time rate of change of total angular momentum of a system of particles, that is equal to the net external torque acting on a system of particles, and this is in analogy with Newton's second law of motion. Now if tau external, that is equal to 0. So here if tau external is 0, then in that particular case angular momentum, that will be constant, because dl by dt, that is equal to 0. So differentiation of L with respect to time t, that is 0, means L, that should be constant one. So we can say if the net external torque acting on a system of particles, that is equal to 0, then the total angular momentum of a system of particles, that will be conserved. It implies that it remains constant. Clear to all of you?